Hi everyone, my name is Mustafa Mansour. I am the Principal Product Manager for Amazon Kinesis Data Firehose. I would like to welcome you for having you today with us in our webinar. I'm going to talk about how you can use Kinesis Firehose to simplify your Amazon S3 analytics workflows. I will start by discussing the characteristics of data streaming, how it's different from bulk data. We'll go and provide an overview of Firehose features and architecture and how Firehose fits in the streaming ETL workflow. ETL is extract, transform, and load. Next, we will go over the best practice on how you get your S3 ready for analytical queries using Amazon Athena, Presto, Redshift Spectrum, and how can you optimize your S3 cost for this querying, analytical queries engines. So what is data streaming? What are the typical characteristics that differentiate streaming data from bulk data? Streaming data is a high volume data that is generated continuously by thousands of data sources that send data records simultaneously in small sizes, usually in the order of bytes and kilobytes. Some examples of streaming data are log files generated from servers, devices, or applications that you're running in your environment. It can be e-commerce purchases, IoT devices generating thousands of data from thousands of producers, in-game player activity, information from social networks, and so on. Basically, you will find that streaming data comes from a wide variety of almost all industries. So what's the workflow for data streaming? Customers usually start by pushing data from their end devices to a streaming ingestion solution, like a data collector. So you have your sources, you have your producers, and then you push this thousands of producers to a data collector. That will be the streaming ingestion platform. Once you collect the data, you will do some data transformations and data processing. For example, you may want to add new fields, like tag your data with extra information as they come through your ingestion pipeline. You may want to filter, drop some fields, mask some sensitive data. Maybe you're running social security numbers, phone numbers, email addresses, things that you don't want to save on your data lake or show on your um, visualization tool. So this is the kind of transformations that you will do as part of your streaming ingestion. You can also convert your data from one format to another format. Maybe the data is coming in a raw format or Apache log, and you want to convert it to JSON or Parquet or something similar. So it's ready to be consumed by the analytical application or by the querying engine that you have. After data transformation, then it's the delivery part and how you handle delivery failures. And the delivery can be like an S3 as a representation for data lakes, or it can be Redshift for data warehouse, or OpenSearch as a data analytical service. In this session, we'll focus on S3, of course, and we'll talk about how to optimize the cost for S3 and how to make S3 more efficient for the next downstream analytical application, which in this case can be Amazon Athena, Presto, or QuickSight. You will use this kind of tools to analyze and visualize your data. Firehose comes in the picture to facilitate the ingestion, transformation, and delivery part of your data. So if you look at your streaming workflow, Firehose is the data collector. It will allow you to do some transformations, and it will deliver and handle the delivery failures if there are any problems with your destination. Firehose is a near real-time streaming ETL service, very easy to use. You can set up your stream in minutes at any data volume, at any scale, with very low cost. You're talking about few cents per gigabyte. So to go a little deeper in Firehose, I want to give you an overview of what Firehose brings to you as a streaming ATL. Firehose can extract, transform, and load data. On the extraction part, you can ingest your data to Firehose using our API. AWS SDK kit, you can do direct put in API and push the data to Firehose. The other option, if you're using Amazon Kinesis Data Stream, then there is a direct integration between Kinesis Data Stream, KDS, and Kinesis Firehose. We can pull the data from whatever shard or stream that you have configured on KDS, Kinesis Data Stream already. Firehose also supports more than 20 AWS services out of the box, which means that if your data origin comes from CloudWatch logs or from AWS IoT, WAF, SNS, EventBridge, or any other AWS service, you can directly push the data from that service to Kinesis Firehose. If you're running your custom app, maybe in a container or a VM or your own on-premise device, and you want to get the data out, you can also use agents, either Kinesis agent, which is an agent that the Kinesis team built, or you can use an open source agent like FluentD or FluentBit or Apache NiFi. Firehose has an integration with all these. So whatever works in your solution and your environment, you can just use it to send data without writing any code. When it comes to transformations, Firehose gives you two options. The first option is Lambda custom transformations. Firehose can trigger Lambda, and you can write your own code to do whatever transformation you want. Or you can use the built-in transformations that Firehose already natively supports, like converting from JSON to Parquet, or doing S3 dynamic partitioning, record delimiters. This means that when packets come to Firehose, you can break them down and break down the JSON messages based on a custom delimiter or a well-known delimiter like a new line, and push the JSON messages to your destination like S3. You can compress and decompress if you want to save on cost, I/O. Then you can either compress your data before it comes to Firehose, and then you can decompress it from there, or you can compress the data from Firehose to your destination, like S3 or OpenSearch, Redshift, or any other destination you have. And one more feature that Firehose natively supports is buffering and batching. This is very, very common if you're going to Amazon S3. You want to save on the I/O cost, the number of API calls that you're going to make to S3. So one option here is buffer the data when they come in. You can batch them together before you push them to Amazon S3. And there are different ways of how to buffer. We're going to talk about them in details later. But as a high level, you can either do time limit buffers like a window, or you can do based on a file size or an object size. Like aggregate packets coming to you until you reach a certain object size, then you push that object to S3. When it comes to destinations, Firehose supports more than 15 destinations. The AWS native destinations are Amazon S3, Redshift, OpenSearch, and API Gateway. In addition to AWS destinations, Firehose supports third-party destinations. There are a lot of them: Splunk, Datadog, New Relic, Dynatrace. There are a bunch of destinations that Firehose supports, and every quarter there will be a new announcement with another destination coming in. Firehose has a lot of benefits that it can bring to you. It's very easy to use. With just a few clicks, you can create your delivery stream. You select your destination and start the stream from your source to your destination. You can connect to your destination in under a minute with no code required. With Firehose, you automatically provision, manage, and scale your network, scale compute, memory, any network resources in a fully managed service. No ongoing administration is required from your side. It's a serverless service that's offered by AWS. It will allow you to easily transform raw streaming data from one format to another, or to buffer or to compress, the things that we mentioned in the previous slide. Again, and can do that without any code required from your side. It's a serverless service that comes with elastic scale, which means that it can go up as your data increases, as your volume increases. You don't have to provision clusters. Firehose will take care of automatically adjusting to the amount of data that you are pumping up into Firehose. And last, Firehose comes at a very low cost. You can prepare your data and ingest it, send it to your destination at just few cents per gigabyte at any scale that you have. So what is the best practice for getting your S3 ready for data analytics and analytics tools like Amazon Athena or Presto? So if you look at a blog that was published by the Amazon solution team, they talk about 10 performance tuning tips that you can do with Amazon Athena that will make your queries more efficient. It will decrease your cost, decrease the amount of data that you're going to scan. So that's how it decreases the cost, and it will improve time to insights. How long it takes until you get your visualization and your data analyzed. So what are these tips? There are a couple of them here that relates to S3. First, partition and bucket your data. When the traffic comes in and you're going to store it in S3, you don't want to store it in one big bucket. Then Athena will spend long time trying to scan this bucket and get you the results you want. So you want to split the bucket into smaller buckets that make sense, either depending on, let's say, a customer ID or a transaction ID or a device ID or something that's meaningful to your data. So when you try to run a query, you only select the bucket that relates to your query. So you decrease the amount of data that you scan and you increase the time, or you increase the velocity to get data analysis done. Next is compression. So use compression. It's more efficient for Amazon Athena, and it decreases your cost. You can also optimize the file size. You don't want to run or load too many small files. That increases your cost. You want to optimize the file size, and the recommendation is usually around 128 meg. That's like the sweet spot for a good file size that Amazon Athena can read. Last is optimize columnar data store. This means that if your data is stored in a format that like Parquet or ORC, it can be easily read from Amazon Athena or from other analytic queries like Amazon Athena. So how can Firehose solve these problems? Firehose supports dynamic partitioning and custom bucket prefixes. This means that you can set the bucket prefix. You can call it like my app, and then you can break it down by year, month, date, and hour. That's one option. Or you can actually create these buckets on the fly based on some value that's inside your payload itself. And we'll discuss that in the next slides in details. Firehose can also support different compression techniques. gzip, Snappy, Hadoop compatible Snappy data. There are different options that Firehose supports for you natively. You just select it as the traffic goes through. Firehose will compress and send to S3. Next, S3 buffer hints to optimize the file size. So one of the buffer options is the file size. Firehose can aggregate traffic as it comes to it and monitor the file size once it reaches a certain size that you specify, maybe 64, 128. Once that file size is reached, then it will push that file as an object to Amazon S3. You can also do it based on time. If you want data to come faster and you don't want to wait, then you can set like a buffer interval time, 60 seconds or 10 minutes or 15 minutes, whatever makes sense to your use case. And last here is conversion, the data format conversion from, let's say, XML, CSV, JSON to Parquet and ORC that are recommended for data store formats for Amazon Athena. So let's dig deep into these features, understand them a little bit more. Starting with dynamic partitioning. The goal here is that if you look at the left side, you have a JSON example. Traffic is coming in, let's say customer ID, the one that's highlighted here in a bubble. And as the traffic comes to Kinesis Data Firehose, you want to make sure that when you push it to S3, you create buckets and folders on the fly. And the folder name, the prefix name, is basically the value of the customer ID or whatever key that you have in your JSON example here. So let's say I choose customer ID as my key, and that value will be the name of the prefix of the folder. Under that, maybe I want to categorize the data based on the date, like year, month, and day. So Firehose can allow you to do that with just a few clicks. This is a screenshot from Firehose. You can do it with API, CloudFormation, console, different options, Terraform. There are a few options on how you can configure Firehose. This is just a screenshot from the console. So the first thing you do, you enable inline parsing for JSON messages. So you say enable. And then the second step is listing down your keys. The keys here means the prefixes, the folders that you want to create. So the first prefix will be customer. And that will be the way you put the value is .customer underscore ID. This is a JQ syntax, if you're familiar with JQ. So that's the same syntax is used here. That syntax .customer underscore ID basically takes the value from the customer underscore ID key and create a folder on S3 with that value. If you want year, month, day, hour, it does the same thing. You just put the syntax from JQ, and it will create the year, month, day, and hour. And that will be reflected in your S3 buckets. Instead of customer ID, you may want to use transaction ID. I see that with a lot of e-commerce customers. Maybe if you're doing CDC, you may be interested in a table ID instead, or maybe a schema. And then you have multiple schemas will go to different folders. Another use case that I see for customers using dynamic partitioning, especially when they have IoT data, is the type of device. So they categorize their prefixes on S3 based on the type of device, Android versus iOS versus Fire TV or something else. Another use case is log type. So let's say you're ingesting logs from CloudWatch logs or VPC logs, and you're getting different types of logs, info, error, warning. There are like 6 or 7 different types. So you may want to have every type goes to a different folder, and that can be your key and value. Another use case is API version. If you have multiple API versions or multiple versions for your application, and you may want to keep different versions in different buckets, and you scan this version or this bucket from your Amazon Athena. So based on version 1 or version 2 or something like that, you can tell Firehose to monitor the version number and put it in the right bucket for every packet that comes through. With dynamic partitioning, you get a lot of benefits. You eliminate S3 post-processing. So if you don't do it in transit on the fly from Firehose or from your streaming platform, then you have to wait for the traffic to reach S3. And after that, you're going to run Glue or Spark Job, an additional ETL service to get your packets or your data repartitioned in S3. The benefit of doing it on Firehose, it's inline. You don't waste any time when the data reaches the destination. It happens inline. So your you reduce the time to insights. Also, there is no additional cost from running Glue or Spark jobs. That consumes extra cost and it consumes extra time until you get um, analysis to your data. Another feature that we have is the buffer hints that's supported by Firehose. There are two options, and you can use both of them. It's not like one or the other. You can actually use both, and whatever happens first will be triggered by Firehose. The two options are time-based buffer, volume-based buffer. The time-based buffer is configurable. You can select your configuration from 1 minute up to 15 minutes. By default, we have a 5 minutes value. But it's a configuration option. You can put the value you want. Same for volume. We can go from 1 meg all the way up to 128 meg. And you can put the configuration option that you want. 128 is recommended if you're doing Athena or Presto or Redshift Spectrum. If you configured both, then Firehose will flush the buffer based on whatever value is being triggered first. For example, if you're sending at very high speed and you are filling the file size very quickly, maybe in 10 seconds or 20 seconds, we're not going to wait for the time base. The file size has been completed, so we're going to flush the buffer and send it to S3 right away. And the other way around, if you're sending low volume, then we will wait for the time-based buffer hint to be consumed. And then if you're done with, let's say, your 10-minute or your 15-minute configuration, then we're going to send the file that we have been accumulating. Another feature is Firehose data format conversion. It's natively supported by Firehose. Firehose can convert from JSON to Parquet. Parquet is a columnar data storage. Parquet and ORC, they are very popular in the world of analytical engines like Amazon Athena and Redshift. This is a recommended columnar data storage format that you should be using. It saves space and it makes your query much faster and reduce your storage cost because it has built-in compression in it. Firehose will use the Snappy by default as a compression option that comes with Parquet. If you look at the picture or the diagram on the right side here, the traffic is coming to Firehose. Firehose will do JSON to Parquet. So if your traffic is not in JSON format, maybe CSV or Apache logs, then you can trigger Lambda. Firehose supports Lambda as one of the options for data transformations. And the solution team from Firehose has created a bunch of Lambda blueprints. You don't have to write any code, just select the blueprint and it will do the CSV to JSON or the Apache log to JSON for you, the conversion part on your behalf. And then traffic will come into Firehose in a JSON format and from JSON to Apache Parquet or Apache ORC to your destination S3 bucket. Firehose has extra options in addition to delivering data to the destination bucket that you choose. Firehose can deliver any failures. Let's say a packet has malfunction or the transformation process is not complete successfully, then Firehose will send that transformation failure or the records that failed from the transformation to a failure S3 bucket. You also have the option to send all your raw data without any transformations to a backup S3 bucket. This is used in case you want to keep a copy of all the data without any transformations, maybe for audit reasons. You just want to save it for the next 3 years, 5 years, or whatever time period or policy you have in your organization. So for that, with a stream that comes into Firehose, we can apply the transformation for it and send it to the right destination, but we can also create a backup raw data without doing any transformation and send it to the backup S3 buckets. Okay, so for customers who have used this solution before, you will find that we actually have customers from almost all industries. You will find Autodesk, Hayat, Zillow, Okla. There are different. This is just a small set, but there are thousands of customers who are using Firehose and S3 today. Um, Orange Theory, for example, uh, they started in the pandemic. They started offering virtual classes and collecting member information, analyzing them like heart rate during the virtual class, and sending them to the coaches and customize the program for their members. That generates a lot of streaming data, and it goes through Firehose to S3. Visio, a similar kind of use case, but this time it's actually billions of events that get generated from TVs and connected devices. Zillow, um, the home valuation and the characteristics, the data on all the properties, they go through streaming process, Firehose to S3. And same for Okla, Woot, Autodesk, and Hyatt Hotels. In every industry, there is a need for streaming, and Firehose and S3 have been very efficient, working great for our customers. And for resources, my last slide for the day, if you want to go and learn more about Firehose, there are a bunch of resources that are available to you. There are labs and workshops that we created. You will find labs that are about 20 to 30 minutes each lab on any of the topics that we discussed today, parquet conversion, dynamic partitioning, different destinations. So the link will be the first bullet. And then if you want to learn more about different options and features that are offered by Firehose, there's the documentation, and there are different blog posts as well. And last is video. So there are options to see the console and how you can configure features if you're more into video training than reading documentation. With that, I conclude the slides for the day.